7.2 Discrete random variable, which is the learning outcome. Construct the probability distribution function. As I told you, we'll be having as a PDF, and find probabilities from probability distribution table. So we're going to proceed for the next one, which is a definition of probability distribution function, which is we'll be having these two properties, which is you must make sure the probability distribution function, which is x is equal to x over here, it must be in between of 0 and 1. Either will be equal to 0 or will be equal to 1 here, but it must be in between of 0 and 1 only. And the summation, the second one will be the summation of the probability distribution function must be equal with 1. Let's proceed because we already discussed this one. So let's proceed with example 7.1. Okay, I hope you already read about this one, which is it is given to some data. Okay, this table called as a frequency, it is called as a probability distribution table. So this is a number of cars, which is 0, 1, 2, 3, 4, and 5 here. So the probability distribution function here, it is given to when the number of cars 0 will be having a 0.1, the number of cars 1 will be having a 0.1, and so on here. And the total of the probability distribution here must be equal with 1. You must put a you must make sure, you must check it must be equal with 1. So the next one, the question asking show that x, the capital of x here, is a discrete random variable, which is you are going to use what you already have before, which is these two properties here, which is the first one must be between of 0 and 1. So you can see all the probability distribution here, it is a between of 0 and 1. And the second property, which is the summation of probability distribution function here, is equal to 1, right? So we're going to prove which is you must make sure the probability of distribution function greater than 0 for all x, and which is the summation for the probability distribution function here is equal with 1. Sum up everything here, so it will be equal to 1. So it is proved that it will be a discrete random variable. Okay, so is it okay with you? And then for the next one, which is for question number 2, the question asking what find the probability that 2 cars or less will be sold the next day. So if you want to write it in the form of inequality, so you'll be having x less than or equal to 2, which is what in this case, in this topic, your inequalities is very important. So you'll be having probability of x is equal to 0, x is equal to 1, and x is equal to 2. So the probability of distribution function for the x is equal to 0 will be having 0.1, x is equal to 1, 0.1, and x is equal to 2 will be 0.2. So therefore, you will be having 0.4 here. And as for the example 7.2 here, probability distribution function, okay, sometimes they will give you okay, sometimes they will give you which is a probability of x here. The function will be having kx squared. Okay, so for x is equal to 0, 1, 2, 3, 4. So the question is going to find the value of constant k. So if you try to look at here, they are given some function for this probability distribution function. Okay, so don't worry, it will be defining the same thing. You must make sure these two properties before from the definition, it must be between of 0 and 1, and another one will be having what the summation of it must be equal with 1. So we'll be having the second properties here. So you know you'll be having probability of x is equal to 0, 1, 2, 3, 4. Where do we got it? We got it from here, already given to you here. And the next one, use this function already given to you, kx squared, is it right? So just substitute x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4. So from here you can have the value of k. And the next question, obtain the probability distribution of x. So actually for question B, much easier if you are going to put it in the probability distribution table. Okay, so just put over here, when the x is equal to 0, what do you have for the probability distribution function here? And when the x is equal to 1, what do you have for your probability distribution for when x is equal to 1, and so on here. And if you want to check, as I told you, the summation of 0, 1 over 30, 2 over 15, 3 over 10, and 8 over 15 here, it must be equal with 1. And the next question, For question C1 Roman, the question asking to have probability of x is equal to 1 or x is equal to 4. So you just can get it from directly from the table itself. So x is equal to 1 is over here and x is equal to 4 is over here. So you'll be going to have 70 over 30 here, and in between, which is you'll be having probability of x minus 2. It is given a modulus less than 1. So you may look in your algebra interpretation here, AI, that you already learned before. So you'll be having what? You can open up, will be between of negative 1 and 1. So solve it, you just want x here. So that's why you'll be having between of 1 and 3. But as I told you, the inequality in this topic is very important. They just want in between of 1 and 3. And the 1 and 3 is not included, so therefore you just have probability of x is equal to 2. So therefore this will be your answer. As we proceed, example 7.3, I believe they already discussed about this one, so let's just proceed about this one. So this is just some graph I already give you. The graph I already give you just now, not just now, just previously, it is showing that it will be having some discrete probability distribution function. So let's proceed, which is about the CDF. Cumulative distribution function for discrete random variable. Okay, this is CDF. Okay, so what's the learning outcome? You'll be having cumulative distribution function. What is it? And probabilities from cumulative distribution function. So as we know, we'll be having CDF here, which is cumulative. It accumulates. Okay, so the definition will be having what here? So the definition will be having as we know PDF, we are going to represent it as small letter of f. As for the CDF, we are going to represent it as a capital letter of fx, which is the property of x here must be less than or equal to x here, which is it is a summation, an easy way to say in that way. So don't worry, we're going to proceed to example 7.3 here. I already have a solution, don't worry. So example 7.3, PDF already given to you this one. So very clear about the PDF. Just proceed. First question asking to have your CDF, okay, and the next question will be having sketch the graph of the CDF. Okay, let me tell you another one thing. Okay, as we know, there is difference about the PDF and CDF. PDF we are going PDF we are going to write it as the property of x is equal to x over here, right? But as for the CDF, we are going to represent it as the property of capital of x here less than or equal to x. If there is question that already put it over here, so it is shown that it will be CDF. Okay, please be clear, please put some notes over there. Okay, so the first question, find the CDF. Okay, to find the CDF, what can you do over here? It is accumulate. So when the if you try to look at here, just look at this one first. Okay, as you can see from the cursor, which is this part, which is if you try to look at here, property of x is less than or equal to 0. So you'll be having the summation of x, property of x is equal to x here. The PDF here will be equal to 0, right? So it will be 1 over 8. When the x is less than or equal to 1, so we'll be having some summation from the 0 until 1. So from the 0 until 1, when the x is equal to 0, you'll be having 1 over 8. When x is equal to 1, you'll be having 3 over 8. So sum of it, you'll be having 4 over 8. So x is less than or equal to 2, so you'll be having 7 over 8. Less than or equal to 3, so you'll be having is equal to 1. So that's the meaning of it. So we can represent it as a capital of F0, a capital of F1, capital of F2, and capital of F3 to represent as a CDF. This is a representation about your CDF. Okay, please put some notes over there. There is difference between PDF and CDF. So after you've got your CDF, so you're going to put it into your cumulative distribution function in your table here. So you can see, which is all of it, which is must be equal to 1 here, and also can be written in the piecewise function. In the piecewise function, he will be having capital letter of fx is equal to, we'll be having some piecewise function here, Okay, the important part I want you to highlight, please highlight and please put some notes. It must be from 0 until 1. 0 will be going to have x less than 0, and the next one will be x between of 0 and 1, and the last one will be 0 when the x is greater than or equal to 3. And this is the graph if we try to look at the graph. Okay,